This is a cool problem. Suppose there are two sets A and B. We're not given these sets, only their intersection and union. And from that, we don't have to figure out what the sets are, just how many different sets are possible for set A. First observation is that A cannot have anything other than these 6 objects, because if A had, say, the number 8 in it, then that would make its way into the union, right? A has to be a subset of 1, 2, 3, 4, 5, 6. And A has to contain 1, 2, and 5. Because if A does not contain 1, 2, and 5, then the intersection wouldn't contain these numbers. So we know for sure that A is going to have 1, 2, and 5 in it. And we know that the only things that we can add to this set are 3 or 4 or 6. So let's say A is just this set. That means that B could be, well, B must have 1, 2, and 5. And then for the union, because A doesn't bring in any of 3, 4, and 6, so B would have to have 3, 4, 6. So that's one possibility, right? If we take these two sets, A 1 to 5, B 1, 2, 3, 4, 5, 6, then the intersection is 1 to 5, the union is 1, 2, 3, 4, 5, 6. Okay, let us notice right now that we could swap the two. So A could be all the numbers from 1 through 6, and B could be 1 to 5, and that might work. But for now, to be systematic, we're going to wait with that case. So we can also choose to add the number 3 to A. So then it would have 1, 2, 3, 5. And then 4 and 6 would have to be in B, otherwise the union is not big enough, and 3 is not allowed, because if 3 is in both sets, that would mean it would be also in the intersection. So it looks like basically we have to distribute the numbers 3, 4, and 6 into one of the two sets. So we could just put 4 here into A, and then 3, 6 would have to come into set B. Or we could put in 6 here, and then 3 and 4 has to join B. So we already have 4 different options. And whenever counting, it's always a good thing to ask ourselves, what are we counting here? Here, we started with the mandatory 1, 2, and 5 and added nothing. Here, we added one possible number. We could add 2 possible numbers, right? So we could add not 1, but 2 numbers. We could add 3 and 4, and then 6 must be here. We could add 3 and 6, and then 4 must be in B. Or we could add 4 and 6, and then 3 must be an element of B. And finally, we could choose to put all 3 numbers, 3, 4, and 6 into A, and then B would have to remain 1, 2, 5. This is the case that we found with the first case. So it looks like there are 8 possible sets for A. Thank you for watching.